Okay, so now we're ready to talk about total surface area of prisms. What we've been doing so far was just the lateral area. So now we're ready to add to that the area of both bases, so we get the entire area of this entire figure, the whole surface area, everything that touches air. And so now, here's what's crazy though, you might make yourself a note, is area formula changes. And so this is a little bit unnerving because the area of the bases is going to change every time depending on what kind of shape you have for your base. So just to be clear, this is lateral area is perimeter of the base times the height of the prism, the distance between the bases, plus 2, and then the big B stands for 2 times area of the base, and 2 times because there's 2 bases, right? Okay, so let's look at this first example here. So it says find the surface area of each prism. Round your answer to the nearest tenth if necessary. So our first step when we look at this is what are our bases? Which sides of this shape are not rectangles? And so we would say the front and the back of this shape. These hexagons are not rectangles. These are our bases. So this is a base and this is a base. The next thing we want to look for is what is our height? What is the distance between the bases? So the distance between the bases here is shown to be 12. And now we're ready to find the surface area. I'm just going to call that SA. So we're talking about perimeter of the base times the height plus 2 times area of the base. And no, you don't have to write all of this out, but initially, while we're still learning what all of these letters stand for in the formula, this seems to make a whole lot more sense to me than trying to remember what P, H plus 2B stands for. But let's walk through that real quick. Perimeter of the base is what P is. Height is what H is. And then, let me go yellow. And then B, capital B, stands for area of the base. Okay, so for the perimeter of this base, we've got 1, 2, 3, 4, 5, 6 sides, and each side is 6. So we're talking about 6 sides times 6 each, right? Because it's 6 on each of these. So if I were to add up all 6 of them, I would get 36. We already said that our height was the 12 plus 2 times area of the base. 2 times big B. Okay, so just to be clear, this was the height, this was the P, that's the perimeter of the base, this is the area of the base. Okay, so if you're okay with it, I'm going to go ahead and do 6 times 6 times 12 in my calculator, and that part is 432. That's the lateral area. That's the perimeter of the base times the height. Then for the area of the base, I have to think to myself, well, what shape is my base? And in this case, it's a regular polygon. So because this is a regular polygon, that's how we know that we have to use 1/2 apothem times perimeter. So you're going to have to look at your area formula sheet from the last chapter and see what formula you need. So 1/2 apothem times perimeter. Okay, so let's pause for a minute. I want you to think about what do I know, what do I not know? A stands for apothem. We see the apothem is right here, but we do not know its length yet. Do we know perimeter of the base, perimeter of that regular polygon? Yes, we do. So I'm going to do a couple of things here. I'm going to recopy the 432. And then I'm going to cancel out 2 times 1/2 is just 1, right? So instead of writing all that out, I'm just going to write plus. That canceled, so A times And then the perimeter we said was 6 for each side times 6 sides. This was perimeter, right? So then the only other thing that we have to find is the apothem. So let's go back to our regular polygon strategies, right? How is it exactly that we find the length of that blue apothem? Well, it's all about if we can find the degrees of this red angle here, then that's the key to the whole problem. We can find that apothem. So to find that red angle there, our strategy is to draw a line from each vertex of this hexagon into the center of the shape. And for now, we won't worry about the apothem yet. And the reason why we do that is this is going to help us find that angle that's the key to this whole problem. Because we know that all of these center angles make a circle together. So if I do 360 for the whole circle divided by 6 equal angles, each one will be 60 degrees. So this is 60, this is 60, this is 60, 60, 60. And now here's the magic, because when I have that apothem drawn in, it splits up that 60 into 30 and 30. So now I can find the length of that green line using a 30, 60, 90 triangle. Tell you what, I'm gonna go over here and draw that 30, 60, 90 triangle a little bit bigger so we can see what it is we're dealing with. So here is the A. Here is the 30 up top and the 60 in the bottom left-hand corner. And then we have 6 as the bottom of this whole hexagon. So I know that I would bust up that 6 into 3 on this side and 3 on this side. Okay, so we know that on a 30, 60, 90, across from 30 is the inside, that this is the 2n for the hypotenuse, and this is the n square root 3 side across from 60. So if our n is 3, then our apothem would be 3 square root 3. So now we can plug that in. I'm going to go ahead and call this 6 times 6, 36. Okay, and then from here, I'm just putting all of this in my calculator. And I get 619.06. Since I'm going to the nearest tenth, I go to the tenths place. I look one place to the right, and because that is 5 or greater, I know that I have to round up. So this will be approximately 619.1. And because it's inches, I know area is always inches squared.